Within the guitar community, there is a persistent focus on original 40-year-old vintage amplifiers. The prevailing assumption is that these specific units possess a sonic character that modern production methods cannot replicate. But the physical reality of a 40-year-old electronic circuit tells a different story. Electrolytic filter capacitors, the components responsible for smoothing out the power supply, have a finite chemical lifespan. Over decades, the internal electrolyte dries up, leading to noise, power loss, and eventual component failure. Carbon composition plate resistors suffer from a similar degradation. After decades of exposure to extreme operating heat, these resistors drift far from their specified values. What was originally a 100 k ohm resistor can drift upward by 50%, throwing the gain stages completely out of balance. Vintage output transformers often carry degraded paper insulation or internal shorts between the windings. To operate safely at modern stage volumes, this original iron frequently requires replacement. Once these critical items are swapped for modern equivalents, the amplifier is no longer truly vintage. It is a modern circuit housed in an aged metal box. Spending premium money on a vintage unit often yields nothing more than an original chassis housing new parts. If the goal is consistent, professional-grade performance, rebuilding a modern unit from the ground up is the more logical path to high-end tone. The modern alternative begins by acquiring a commercial reissue amplifier and completely gutting its internal electronics. We remove the factory boards, pots, and ribbon cables, leaving only the bare steel chassis and the cabinet. Modern mass-produced printed circuit boards are often defined by their limitations, thin traces and board-mounted hardware that can crack under mechanical stress. Contrast that with traditional hand wiring, a thick G10 turret board, discrete components, and 18-gauge Teflon-insulated wire. A more reliable approach is to build a hand-wired AB763 circuit directly inside that modern chassis, using boutique-grade components and robust chassis-mounted hardware. Our objective is to map the exact component-level modifications required to optimize the stock AB763 circuit. This process covers phase alignment, vital frequency response, and long-term reliability. This specific architectural choice combines the physical availability of a modern Fender reissue with the performance of a hand-built boutique amplifier. Our first phase establishes a resilient 6v6 power section. Under heavy load, the screen grid frequently fails. A shorted tube draws excessive current, damaging the circuit board. We eliminate this risk by replacing the stock 470 ohm resistors with heavy-duty 1K 5-watt screen resistors. This higher wattage component serves as a physical barrier. If an output tube shorts, the resistor absorbs the fault and remains intact, preventing a destructive failure loop from burning the internal wiring. We also address the biasing architecture. In a stock configuration, adjusting the bias requires navigating lethal voltages inside the chassis while powered on. We integrate external bias test points, wired to 1 ohm cathode resistors. These are tied to a 10K bias pot accessible through the bottom of the chassis. These upgrades convert tube maintenance into a safe external adjustment. The result is a circuit that's both easier to maintain and more reliable on the road. Moving to the preamp, the stock AB763 isolates the normal and vibrato channels into 2 distinct signal paths. Because of the gain stage configuration, these channels are out of phase. If the builder attempts to bridge the inputs to run both channels together, the signals cancel each other out, resulting in a thin, weak tone. We alter the internal routing so the peaks and troughs of the signals align. Both channels now run perfectly in phase. Aligning the phase makes it possible to route the normal channel directly through the reverb and tremolo sockets, features historically restricted to the vibrato channel. With the channels unified, we can apply a specific EQ modification to the normal channel. Injecting a fixed resistor into the tone stack introduces a Marshall-esque mid-range emphasis. This creates a functional contrast with the naturally scooped voicing of the vibrato channel. The historically redundant normal channel now serves a specific purpose. The amplifier functions as a versatile dual voicing rig, offering traditional Fender cleans on one side and an aggressive mid-range bark on the other. The phase inverter is the engine that feeds the power section. It takes the signal from the preamp, splits it, and inverts 1/2 to drive the push-pull power tubes. A common issue in stock reissues is low-frequency flub or farting out when the volume is turned up. The phase inverter is allowing frequencies lower than the speaker can handle to pass into the power section. To fix this, we lower the capacitor values in the phase inverter. This filters out the troublesome frequencies before they reach the output. To compensate for the tighter low end, we increase the value of the coupling cap located just before the phase inverter. This larger cap allows more mid-range and fullness into the circuit. It maintains the amp's physical body, while the earlier filter prevents the low-end flub. We then look at the negative feedback loop. This circuit takes a small amount of signal from the output transformer and feeds it back to the phase inverter to stabilize the circuit and reduce distortion. We modify the negative feedback resistor to restrict the amount of signal being fed back. This essentially acts as a fixed resonance control. Reducing this negative feedback results in an amplifier that breaks up earlier, with increased harmonic complexity and higher sensitivity to the player's touch. Transitioning to the modulation stages, we start by examining the stock opto-isolator tremolo system used by the factory. Rather than the choppy volume cut of the opto-isolator, we install a bias pulsating tremolo architecture, modeled after the 63 Vibroverb. By modulating the bias of the power tubes directly, the tremolo creates a deeply integrated pulse that sounds three-dimensional, rather than a harsh on and off volume oscillation. In the reverb circuit, we have to solve a notorious mechanical issue, the reverb becoming overwhelmingly wet, even when the knob is barely turned. The cause is the factory use of a 100K linear taper potentiometer for the reverb send. A linear pot adds resistance in equal increments, which our ears do not perceive as a smooth transition. We swap this for a 100K audio or logarithmic taper potentiometer. Human hearing operates on a logarithmic scale. The audio pot follows this natural curve, allowing the resistance to ramp up more gradually in the first half of the knob's rotation. This gives the player highly granular control over the reverb decay. The modulation is no longer an all-or-nothing effect. It becomes a precise studio-grade tool. When we view the holistic scope of the re-engineered circuit, the individual nodes reveal a larger pattern. Superior tone is never the result of a single magic bullet component. Swapping one transformer or a set of tubes cannot fix an inherently unbalanced circuit topology. High-end optimization requires a series of subtle, compensating modifications. It is about balancing the entire circuit so that each stage supports the next. This meticulous approach to balancing components stands in contrast to the inherent compromises of a mass production assembly line, where speed and component cost dictate the final build. Boutique quality tone is the direct result of systemic, intentional engineering. It is a matter of technical alignment, not just expensive vintage branding. This completed hand-wired board illustrates the practical advantages of this rebuilt architecture for the working professional. Housing an optimized circuit inside a modern, replaceable chassis provides total reliability. If the cabinet is damaged on tour, the shell is replaceable, but the circuit remains intact. This method secures the performance guitarists want while bypassing the maintenance risks and the high costs of the vintage market. For the engineers and builders watching, I encourage you to look closely at the commercial layouts on your own benches. Implement these structural upgrades. Realign the phasing and stabilize the power section. Only then will you realize the true potential